Good morning, all of you. So, today, sorry for the late. Actually, can start with the today's session. So, I give the summary. Hello, ఎప్పుడు క్లాస్ స్టార్ట్ అయింది. అవునండి. మ్మ్. కాదు, ఈరోజు లేట్ అయింది. చూద్దాం చెప్తా. మ్మ్. Hey, good morning, all of you. So, last session we started about Java introduction, right? So, what are the areas we discussed in the last session? We discussed about what is the difference between language and programming language. Okay, and I would say we discussed about what is Java and history of Java, and we discussed about Java features, and we discussed about what is the difference between JDK, JRE, and JVM and JVM. Okay, so what is Java features? What is the difference between JDK, JRE, and JVM? And we written one program. We written Hello World program. Okay. So these are all the scenarios which we discussed in the last session. Today the heading is Java program execution flow. The heading is Java program execution flow. Java program execution flow. Generally, today heading is Java program execution flow. So after these concepts, next we have the concept that is Java program execution flow. I can show you. I can use MS Paint, and then through that we'll try to understand it. Okay. Now there is a so first basically we will write the Java programs. Okay. Java programs. Guess only taken permission only 5 people, but 11 members are joined. I can verify. These are the only 5 persons. Sweta, Rajkumar, Deepika, Pradipti, and Lavan Kumar, you're online or offline? Next, who is this Miley Srinivasrao?
Sir,
Yes, yes.
today bus late, sir.
You're offline or online student?
Offline, sir, but take this your permission, sir. Just
From whom?
2 members, sir. మీ పక్కన కూర్చున్నాం కదా సార్ 2 members. శ్రీనివాస్.
Next, Nandan Pallapu. Nandan Pallapu. Next, Pradeep Rajkumar. Rajkumar. Next, Deepika and Sweta. Okay. Hmm. So coming to here, basically we can write Java programs. So all Java programs called source files. Okay, initial whatever the programs we are writing, all programs we can I can say source files. Source files mean initial files. Like for example, if I write the demo.java, demo.java, this is the source file, right? This is the source file. Okay, and this source file we can compile. There is a compiler tool which is available in the JDK folder, and basically there is a compiler, and you can compile. Compiler, the tool is compiler. The command is javac and demo. Javac and demo, and this is the compiler. So what the compiler will do? It will check the syntax mistakes and all, everything it can check, and then I would say if there is no mistakes, then it can compile source code to bytecode. Bytecode is the intermediate language. Bytecode is the intermediate language. This cannot be understood by the human. Bytecode, also called as intermediate language. Why we are saying intermediate language meaning this bytecode cannot be understood by the machine, cannot be understood by the human as well. This is dot class files, demo dot class files. I can show you practical as well how bytecode will be there, and will is it visible for everyone or not. I can show you as well. Okay, initial files are called source files, and we can compile by using command that is javac demo and demo.class. Okay, and this bytecode cannot be understood by the human, also cannot be understood by the machine. But this bytecode can understand only one person, that is JVM. In our case, our mother language might be Telugu, might be Kannada, might be Hindi, right? Same way, JVM also have the mother language, that is bytecode. This bytecode cannot understand by the human. Like human also cannot understand. That I will show you last session which we written. There is a folder which I created right now. If I open this one, there are two files are available. One is .java. This is the file which we written in the last session. And when we compile, one dot class files will be created. If I open this one, you guys can you please read this? What all these statements? Will you able to understand this one? No, because we cannot understand. Even same way English also cannot understand directly because that is the reason we are calling this is called intermediate language. Cannot be understood by the human, cannot be understood by the machine. Okay, coming to here and where I am going to paint. Uh, bytecode can be understand only one person, that is JVM. How JVM will come into the picture? We have to tell to the JVM. How you can tell? And here also we return source file. We are telling to the compiler, hey compiler, there are so many source files which I written. From that, can you please compile only this file? I am telling through the command. Okay, then only compiler will come into the picture and it can check the syntax. Any syntax mistakes will be there or not there. If not there, it can generate. Who can generate? Compiler. Compiler is the tool which is available in the JDK bin folder. It can generate bytecode. This is the intermediate language. Bytecode means this cannot be understood by anyone. This language understand only one person, that is JVM. JVM mother language is bytecode. JVM mother language is bytecode. JVM will understand only one language, that is the byte language. Okay. Now I would say here I will call JVM. Hello JVM. The command for calling the JVM is Java and file name. Okay. So I'm not mentioning dot class because JVM other already mother language is dot class files. Okay. So again, no need to mention dot class and all. Right? Okay. Hello.
Okay, sir.
Java C and then Java demo and uh, now the JVM come into the picture and when I click on this, now the JVM come into the picture. This is the JVM. JVM architecture will be there. That is also very important. So JVM come into the picture and it can load dot class files into the JVM and it can have the memory and all, and there is a execution engine as well. There is a JVM architecture. There is a complete diagram on it. We can discuss today our next session. We can discuss about the JVM architecture. So the thing is, when you give the command, JVM will come into the picture and then it can start its process and then it can give the final output. Meaning, it can convert bytecode to machine language. Okay, it can convert to bytecode to machine language. It can convert to bytecode to machine language. So every machine also have the like a Chrome architecture. So in the Chrome architecture again bytecode will be converted and then finally we will get as the result. Okay. So this is the thing of this entire structure is called, finally you can get the output. This entire structure is called Java Program Execution Flow. Java Program Execution Flow. Java Program Execution Flow. I hope you guys are clear with my statement, what I'm saying. I hope you guys are clear with my statements, what I'm saying. Whatever the initial Java files we are writing, all initial files are called, whatever the Java files we are writing, all initial files are called source files. And source files, we are telling to the compiler, hello compiler, I written source files, can you please compile? What compiler will do? Compiler main purpose is it will check the syntax mistakes like I mean I would say semicolons and semicolons and commas, full stops, everything it can check. Okay, and it can check, and then compiler only it can generate the bytecode, that is dot class files. Okay, dot class files can contain only bytecode. Bytecode cannot be understood by the human and cannot be understood by the machine also. That is the reason we are calling as intermediate language. This language will understand only one person, JVM. How JVM will come? We need to tell to the JVM. What is the command to tell to the JVM? Java demo. Why I am telling Java demo? I am telling to the JVM. Hello JVM, there are number of dot class files, and can you please convert this bytecode? Can you please take into uh, bytecode? uh, what JVM will do, when you give the command, then JVM will come into the picture. It can load the bytecode into the JVM, and then it can convert to bytecode to machine language. Bytecode to machine language. Machine language means like 0111 like that. Binary code will be there. So it will be converted like this. I hope you guys are clear with my statement. So this is the complete diagram of Java program execution flow. Java program execution flow. Okay, so I can show you practically as well. This is the theoretical, and then we can see practical as well. For example, here I can take. So see here, actually we already written one program. The same program I can remove and then I can run. Then I can show you. Take a file, tester document, test.java. Public static void main and string. I can say this is the scope of the class, and this is where actually I would like to take system.out.println, and here I would say some message like search software. This is the simple message which I am writing. Okay, the same program. Uh, this is what file. This is called source file, right? This is called source file. Okay, this is called source, and I need to tell to the compiler, hello compiler, I written one source file, can you please compile? Then what is the command? Open command prompt and tell to compiler. C means compiler. I am telling to the compiler demo.java, and uh, file name is test.java, right? Test.java. So what it is doing, it is checking the syntax mistakes and all. Syntax mistakes and all. And immediately it can generate one dot class files. Who generated this one? Compiler has generated this one. If I open this one, if you can see here, you will be understand this one. No, even machine also cannot understand directly. Then we can tell to JVM, hello JVM. What is the command for the JVM? Java space test.java. I'm not mentioning dot class. Why? Because JVM mother language is the dot class files. Okay, if your mother language is Telugu or Kannada, so why again no need extension of dot Telugu dot Kannada, right? Already you can able to understand. So same way here also no need to mention dot class, because JVM mother language already dot class files. Again no need to mention dot class. No, that is not a good programming, right? So that is the reason here also I'm removing Dart class. When I click on this, you can see here Subway Software Solutions Private Limited. So if if I miss any semicolon and all, and so immediately it cannot generate any Dart class. So compiler it can check. I'm removing this one, and so I can open Java C test.java. So you can see here it is checking the I would say syntax mistakes and all, and it is telling to her, hey boss, you missed the semicolon. Can you please? So at the line number 6, where you can see the line numbers and all in your notepad, this is the bottom. Okay, line number 6 and column number 56. Okay, this is the line number 1 and this is the line number 2. Okay, check here. 3, 4, 5, 6, like this. Okay, yeah. I hope you guys are clear Java program execution flow. So once you are familiar with this one, next there is a concept that is Java program structure. Java program structure. This is clear. Next heading is Java program structure. Any years of laptop, like 10 years, 14 years, any project which are related to Java, any project in the world. So Java program has structure. The structure should be like this. So first one is package statement. Package statement. Second one is import statement. Import statement. Third one is class declaration. Class declaration. And after the class declaration, we have variables and we have methods. Any project, any project in the world which are related to Java, the Java, I would say Java program have the structure. The structure is this one: package statement, import statement, class declaration, variables and methods. Variables and methods. I can show you few of the other projects, and then we can verify. So the structure should be the same or not. Okay. Okay, fine. So Java files are available in the core module. I am going to expand main, and where I can go with the models. There is a hello world dot model, right? Uh, Coming to here. So to see this program structure, how they written and all, there are almost 70 lines. You can come to here. So what is the first statement? Package statement. And after the package statement, what we have import statement. So import statement, you can take number of import statements based on the requirement. Okay. So in this program, almost they taken 10. So if you observe in other file, they might be used 20, 30. Import statements are, that is completely depends on requirement. Completely depends on requirement. Next, after the import statements, what we have? Class declaration. And inside the class declaration, what we have? Obviously, we have the variables and methods. What all these? These all the variables. And what all this? These all the methods. These all the methods. Completed? No. 70 lines completed. So see, package statement, import statement, class declaration, variables and method. Any program in the world which is related to Java, the structure should be same. First statement should be the package statement. After the package statement, we have the import statement. That is based on the requirement. You can take number of import statements. There is no limit at all. And after the import statements, we can take the class declaration. And inside the class, we can declare the variables and methods. Variables also we can take number of variables. Variables also can take number of variables and methods also can take number of methods. Any program you can go and then you can check the structure should be like this only. I would go to schedulers. I would open to this program. See this come to here. What is the first statement? Package statement. Now coming to here. Package meaning a collection of classes, collection of programs. For example, if you purchase biscuit packet, that is a packet plus collection of biscuit. Same way, this is the package. Scheduler is the package coming to here, and it can contains a collection of classes. This is the one class, this is the one class. Like that, you can write so many classes. Where the classes are present, in this package. Package meaning a group of classes is called package. Next, import statements meaning any project we can directly, for example, if you are doing the project working on a Java project, and we cannot develop any project with pure Java, we can use other frameworks as well, like front end, all the other frameworks also can use. And if you want to use other frameworks, we have to import those frameworks. We have to import those classes and all. For example, if you see here, there is a along with this, you should be familiar with when you want to work with the real time. You should be familiar with there are some real time tools like Logger, debugging, Jira, Git and GitHub, Jenkins, Docker, and SonarQube, Postman. These are the some real time tools. You should be have the knowledge on it. So coming to here, Logger is the tool actually. Logger is the tool, and I want to use that tool in my uh, project. So how could I use? I need to use the import statement, and so I need to use those classes, Logger factory class, and wherever I want. So here I created one Logger file, and then only I am using out of the frameworks as well. Logger is also out of the framework, so that I am using inside the class. Inside the class. Okay. So based on the requirement, you can use import statement. Next up, class declaration. Class declaration is very important area in Java, I would say Java projects, and in where we can we can declare the class, and inside the class we can declare variables and methods. So variables meaning it can store values, and we can take a number of variables. Methods also can take number of methods. So this is all about Java program structure. Okay, Java program structure. So we'll first we can go ahead with the Java statement. Package statement. Package means collection of, or you can say group of classes and interfaces, and every program package statement. Every program first line should be package statement. First line, every program first line should be package statement. Okay, package means a group of classes and interfaces. Every program first line should be package statement. Package statement. Next we have the import statement. Import statement. So import statements, we can import out of the box libraries based on the requirement, based on the requirement, and for one class we can import for one class we can import number of import statements. Next up. Okay, fine. Now coming to class declaration. Next up. Class declaration. Class declaration is the very important area in program, and which is used to declare variables and methods. Next up, what is variable? Next up, what is variable? Variable is the container which is used to store the values. One class can contain number of variables. Next up, what is method? Methods are used to perform the actions. Methods are used to perform the actions, and one class can contain number of methods. Number of methods. I hope you guys are clear with my statements. You guys are clear with my statements. Java program structure, what we have, also called as this Java program structure, also called as Java program elements. Elements is also same. Okay, elements is also same. There are two names actually, Java program structure and Java program elements. Both are same. Package statement, import statement, class declaration, variables and methods. Class declaration, variables and methods. Package statements, import statements, class declaration, variables and methods. And methods. And methods. Okay, fine, very good. Now after this, we have the concept that is translators. translators. So, what is the definition? What is the meaning for the translators? Translators, which are used to translators, which are used to convert one format to another format, one format to another format. Are you guys clear with my statements? One format to another format. In Java, we have three types of translators. In Java, we have three types of translators. We have three types of translators. What are the three? First one is compiler. Second one is interpreter. Third one is assembler. Assembler. So what compiler will do? Compiler, which is used to convert source code to byte code, which is used to convert source code to byte code at a time. Source code to byte code at a time. Byte code at a time. At a time. Next, what we have the interpreter. Interpreter is the internal component of the JVM. What it will do, which is used to convert byte code to machine language, one by one, machine language line by line. I hope you guys are clear with my statements. Compiler, which is used to convert source code to byte code at a time. Interpreter, which is used to convert byte code to machine language line by line. Next we have assembler tool and assembler translator, which is used to convert machine, as I would say, in old days we have the assembler language as well. Assembler language into assembler language into assembler language to machine language. Machine language. So this is deprecated. Nobody is not using nowadays. As of now, generally I am telling there are three types of translators we have in Java. What are the three types of translators? Compiler, interpreter, and assembler. And what is the purpose of compiler? Which is used to convert source code to byte code at a time. All the lines. If the file contain 200 of lines, it can, I would say, compile at a time. But if you go with the interpreter, it can translate line by line. There are thousand lines. For example, it can take 1 second for interpreting of one line. So there are thousand lines. How much time? Almost 1,000 seconds. 1,000 seconds, which is used to convert the byte code to machine language line by line. After this, next we have assembler, which is used to convert assembler language. This is the deprecated one actually, but the old days, as there is a assembler language also that can also converted into machine language. Machine language means binary language. So these are the three types of translators we have in Java. Okay, very good. So once you are familiar with the translators, next there is a concept that is JVM architecture. Very important. JVM architecture. JVM architecture. JVM architecture meaning Java Virtual Mission. In the name itself, we have the meaning virtual. Virtual meaning, virtual meaning, we cannot JVM, we cannot see with our eyes, because this is virtual. Even JDK team also they don't see. That is the internal program actually. Okay, that is the software, and that is the virtual. Even JDK team also they can't see. Okay, JVM we cannot see with our eyes. With our eyes. Okay, fine, very good. What is the purpose of JVM? JVM is responsible for JVM is responsible for memory allocation, and memory deallocation. Deallocation. Who will take care? JVM will take care. Okay, JVM will take care. Okay, JVM has architecture, guys. That I can show you. Please be concentrate. I go with, yeah. Next heading is JVM architecture. JVM architecture. Heading is JVM architecture. Okay, fine, very good. Now coming to here. So source files. Next source file we converted to bytecode, right? So initially we will write what? Source files. This is called source files. Source files means, I would say, we written some test.java, right? What is this? This test.java is called source file. This is source file. Okay, and where I would say, so initial file is called source file. Got it? Initial file. I want to convert this initial file to. I want to convert this initial file to bytecode. How could I convert? I need to tell to whom? I need to tell to compiler. I am calling the boss. Hello boss. Who is the boss? Compiler. Java C and tester. Test.java. There are so many files in my folder, and I am specifically, hello compiler. I created one source file. The source file name is test.java. Can you please compile? So immediately compiler will come into the picture, and it can check all syntax mistakes and all. If there is no syntax mistakes, compiler only it can generate bytecode. The extension of bytecode is dot class files. The extension of bytecode is dot class files. Test dot class. The extension of dot class bytecode is dot class files. And this is what? This is bytecode. This is bytecode. Okay, fine. Yeah. This language cannot be understood by anyone. Now there is a command to call the JVM. What is the command? Command name is Java. Uh, what is the command, guys? Java and Java C. Somebody is saying Java C, Java C. Java and only tester. No need to mention dot class. Okay. So when you give the command, then who will come into the picture? JVM. JVM is hero of Java. Okay, hero will come. Hero will come, guys. When hero will come, when you call the hero, then hero will come. JVM is hero of Java. Now hero will come, and hero have some internal components. What are the components it have basically? First, it has the component that is class loader. Class loader. Okay, and after the class loader, it has the memories. It has the memory sections. Memory sections. Okay. Hmm. Where I can say this is the memory compartments. Okay. So this component name is class loader. This component name is class loader. I can say class loader. So what class loader it will do? So when you call the JVM, immediately JVM come into the picture, and initial component is class loader. What it will do? It will load all dot class files into the JVM. This is JVM. I can mention like as JVM, and what it will do generally, it will load dot class files into the JVM. Okay. So once after loading dot class files into the JVM, so based on the code, it will allocate the memory. So first memory we have method area. Memories have the names. The names are like, so first one, this is method area. This is method area. And next one is heap area. Second box is heap area, guys. Second one is heap area. This is heap area, and this is called PC register. These are the memory names. PC register, PC register, and third one is native stack. Method area, heap area, PC register, and where we have native stack. Native stack will be lost of this box. Native stack. So in the method area, so initial all our entire code will be stored in the method area. Next we have the heap area. Objects will be stored in the heap area. And PC register. PC register, it can maintain the line's execution information. Which line is executing currently, and which line is executing, will be executed, ready to execute the next. All lines information will be available here. And there is a native stack. Native stack. Native stack means, so to be frank, this entire JVM also developed using language that is the C language. By using Java, we can write C programs as well. So when you write the C programs are called native language because JVM also developed by using C language, right? If you write any C related programs, that will be stored here. That will be stored here. So what are the components we have? Method area, heap area, and PC register, and native stack, and next we have stack, Java stack. I would say I can increase this one. Java stack. So what it will do? This is the Java stack. Java stacks meaning method execution information will be maintained. There are 100 methods in the class. Which method is executing currently? Which method will be executed the next after this method? So these all the information, these memories will be maintained. You guys clear with my statements what I am saying. We are discussing about the JVM architecture, guys. JVM architecture has components. What are the components actually you have? These all are called memory sections. Okay, so there is a component, initial component, that is the class loader. What class loader will do? It can load the dart class files into the JVM. So initially the all the code will be stored in the memory, and it can check if there any objects will be there or not there. If any objects will be there, it can all give the memory in the heap area. So heap area is the memory which is used to store the objects. Next, PC register is the memory which which is used to store the line's execution information. Which line is executing currently? Which line will be executed the next time? Line's execution will be maintained in the PC register. Next, we have Java stack. Java stack is the memory which is used to maintain methods execution information. There are 100 methods. Which method is executing currently? Which method will be executed the next time? All the methods information will be stored in the Java stack. Next, native stack meaning non-Java code will be stored in the native stack memory. These all are memories. These all are memories. Okay, very good. So after allocating the memory, JVM has execution engine. JVM has execution engine. So that is this is the execution engine of JVM. This is the execution engine, and where I would say I can give the this is called execution engine. Execution engine has two components. What are the two components? One is interpreter, second one is JIT. This execution engine has two components. First one is interpreter. So why they two components? First one is interpreter. Interpreter. Second one is JIT. So coming to translators, can you please read this one? Which is used to convert bytecode line by line. So if it is converting line by line, there are number of lines. Obviously, it will take more time. If it is taking more time, if user need to wait such much time, if user will wait much time, then user will come to visit our website. No, no, right? Then user will go to the other website and they can book other products and all. Right? Basically, interpreter. If you go with the only interpreter approach, it will take more time to uh, convert bytecode to machine language. It will take more time. Okay, so it is taking more time. So because of that, JDK team they added one more component to the interpreter JIT. JIT is also translator just in time. That is also one translator that is also convert to machine language. I would say bytecode to machine language. Now interpreter and JIT they both together they convert bytecode to machine language. Now performance will increase or not increase. So that is the reason Java is the high performance language because of these two components. If you go with the only one component, Java is not a highly performance language. When JDK team adds the JIT and interpreter, now Java is the high performance language because of two components. Okay, and here again we have native interface and native libraries. Native interface and this is native libraries. Native libraries. Uh, Native libraries meaning you are writing C language, right? C language also have some predefined classes and all, right? Those predefined libraries will be stored in the native libraries, which are available in the native libraries. And native interface will act as a mediator between native libraries and the execution engine. It will, when you are calling the C programs, then it will act as a mediator and you can load the native libraries into the execution engine. Okay, it will act as a mediator between the native libraries and execution engine. So this complete entire diagram is called JVM architecture, guys. This entire diagram is called JVM architecture. Very, 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 very important. So as a Java programmer, you have to understand how every program internally, every program how JVM is treating internally. Okay, so you have to understand. So this entire complete diagram is called JVM architecture. Normally you can check, there are, Java is the open source, right? You can check, I would say JVM architecture in Java. You will get there are number of source files actually. If I would go, see here, basically, going with this one. See what components we have: class loader, JVM memory and all. Uh, what we have: method area, heap area, Java stack, PC stack, native stack, execution engine, native interface, native libraries. Native. This entire diagram is called JVM architecture. JVM architecture. JVM architecture. Okay, so we'll try to understand each component. So what class loader will do? Coming to here, right? First one is class loader. What is the purpose of class loader? Class loader, we can load the, it can load, which is used to load all dot class files. It can load all dot class files into the JVM. Next, what we have: component method area. Method area, which is used to store all class code, all class code. Next, we have PC register. PC register, it will maintain, it will maintain, it will maintain. Next line, next line, execution information. Next line, execution information. Information. Next we have Java stack. Java stack, it will maintain, it will maintain next method execution information. Next method execution information. Information. Next native stack. Okay, native stack means it, native stack means when we write non, when we write, or else we can write, it can store, which is used to store the non-Java code, which is used to store the non-Java code. Non-Java code meaning obviously C language. Non-Java code. Next, execution engine, execution engine, execution engine, which is used to convert machine language to, I would say, bytecode to machine language. There are internally two components. Already you know the two components. Machine language. Okay. Next we have the native interface. Native interface. Native interface will act as a mediator between execution engine and native interface will act as a mediator between execution engine and native libraries. Native libraries. Again, the question is what is native libraries? Native libraries meaning non-Java related, which is used to maintain non-Java non-Java libraries. Non-Java libraries. So today what you guys will do, you have to revise all these topics. What are the topics we covered today? I give the summary of today's session. Today we discussed about first one is Java program execution flow, and second one we discussed about Java program structure. Java program structure, and after that we discussed about JVM translators. We discussed about translators, and fourth one we discussed about JVM architecture. These are the topics which we discussed. What you guys will do, you can take notepad like this. You can take, the question is Java execution flow, and you can write the flow of this. Next, Java program structure and components is the same. Elements is also same question. If in the integral perspective they will ask like Java program elements also same question. You can write and answer also you can write. Next, translators also you can write the question and you can write the answer. So like this, you have to write like this, and then you have to make it as a PDF. That PDF you can upload to subject. That is your assignment. Assignments are mandatory. Okay, no excuses in the assignments. If you are not doing the assignments,